Factoring polynomials. This is part 3, example 5. Show that x plus 2 is a factor of f of x, then factor f of x completely. Okay, so in example 4, we looked at this, and what we did was take the calculator and we plugged in k straight into x. And if you get a remainder of 0, that means yes, x plus 2 is a factor of f of x. In this case, it says show that it's a factor and then factor completely. So that means we're going to have to factor no matter what. So let's use synthetic division, kind of a refresher from the last section. But we know that we've got x minus k. So x minus k, so we need to have negative 2. And then we're going to pull down the coefficients from our polynomial. So we've got 1, 2, negative 9, negative 18. So remember, synthetic division is kind of a shortcut to long division. So the first term always drops down, so we're going to bring the 1 down, and then we're going to multiply and add. So we're going to multiply negative 2 times 1 and place that here. So we're going to have negative 2, and then come down, we add that row, we're going to get 0. Negative 2 times 0, anything times 0 is 0. Then we add negative 9 plus 0 is negative 9. Then we multiply again. Negative 2 times negative 9 is positive 18. Negative 18 plus 18 is 0. So this would be our remainder. So this does show that f of negative 2 equals 0. So that means x plus 2 is a factor. All right, so that's one factor. So we know we've got x plus 2 as a factor. And then we need to factor the rest of this completely. So if we factored out x plus 2 and we started with an x cubed, we're going to add in our variables again. So we're going to have 1x squared plus 0x minus 9. So we don't have to put a middle term since that is 0. So again, x, since we factored out an x, we know that we start with one exponent lower than what we originally had for f of x. Now, x squared minus 9 is a difference of perfect squares. So we've got x plus 2, x plus 3, and x minus 3. So again, a difference of squares, same binomial, different sign in the middle. When you multiply these using FOIL or distributive property, you will get back x squared minus 9. So x times x is x squared, minus 3x plus 3x, cancel the middle term. 3 times negative 3 is negative 9. Take that, multiply it by this factor, x times x squared, x cubed, x times negative 9, negative 9x, 2 times x squared plus 2x squared. 2 times negative 9 is negative 18. So you can see that that also, if you use distributive property, will give you back the original term. So again, factoring is a way to rewrite something in factored form, but it's still equivalent to the original polynomial if you do it correctly. Both factoring and determining whether a binomial is a factor of the polynomial is important state standards. Almost always, this is something you will see on your EOC at the end of the semester. So not difficult, just something you have to remember. Example 6, modeling real life. A roller coaster starts at a height of 34 feet and then goes through an underground tunnel. The function h of t represents the coaster's height h in feet after t seconds, where t, that's your time, is between 0 and 5 seconds. How long is the coaster in the tunnel? All right, so you can see here 0 to 5 seconds is on the graph. It does go before that and after that, but we know that's not realistic for a roller coaster. So what they're saying is the roller coaster, we're only evaluating for the domain 0 to 5 seconds. All right, but looking at the graph, we can see that there is zeros. Zeros are where it crosses the x-axis at -1, 2, and then somewhere between 4 and 5. So those are what we're going to work with. So let's first look at -1. So if we say -1, we can use the remainder theorem, or we can use synthetic division. So let's take -1 and pull down our coefficients: 4, -21, 9, and 34. All right, again, our first number comes down. Then we're going to multiply -1 times 4. And then we're going to add -21. Actually, that's -4. -1 times 4 is -4. And that gives me -25. Almost missed my negative sign there. -1 times -25 gives me a positive 25. 25 and 9 is 34. And -1 times positive 34 is -34. So that gives me a remainder of 0. All right, so that means -1 would be a 0 of h of t. And let's see what that leaves as the remainder here. So it's going to be 4t squared minus 25t plus 34. So that means we can determine that x, it would be +1, because the factor has got the opposite sign of the 0. Remember, it's x minus k, and x minus -1 is actually +1. So that's just substituting back into the formula kind of backwards. All right, we also can see here that it crosses at 2, or at least it appears to cross at 2. So let's do the same thing, except now we're going to use 2. And then we're going to use this function here instead of the original function. Now, as you can see, the study tip, you can use the original function, but if we use this one, it'll be just a little bit shorter. So bring our coefficients over: 4, -25, and 34. So we're going to bring down the 4. 2 times 4 is 8. -25 plus 8, -17. 2 times -17 is -34. So again, I get a remainder of 0. So again, I can determine that my 0 of 2 is actually a 0. So I can determine the factor is x minus 2 from that. If I want the factor, and I'm using x, I probably should be using t, but we'll change it here in just a minute. And then I have 4t squared minus 17. So if I want to put that as a factor and set that equal to 0, and that's not squared because it was squared over here, and I've already factored that out. So it's just 4t minus 17. Getting ahead of myself. All right, so if I have that and I set it equal to 0, I can add 17. 4t equals 17. Divide by 4. So t equals 17 over 4. 4 goes into 16 4 times, and 1/4 left over. So 4 and 1/4, or 4.25 is where it crosses right here. Okay, so the zeros are -1, 2, and 4.25, but the only ones that actually matter are 2 and 4.25, because we're talking about a roller coaster, which is a real life scenario, talking about time. Time can't be negative, so that means the domain that we're looking at is only from 0 to 5 seconds. So that means the graph is underground from 2 to 4.25. So the roller coaster is underground about 2.25 seconds. So it says, how long is the coaster in the tunnel? The roller coaster is in the tunnel or underground for 2.5 seconds, from 2 to where it comes back up at 4.25. It doesn't ask you for the factors, but if it wanted all the factors, it would be x plus 1, x minus 2, and 4x minus 17. Again, you could change these to t's. I mix these between t's and x's. Let me fix that actually and use t's for all of them. All right, so I've changed the variable here so that they all say t. I'm so used to using x's for most equations that I just used x without even thinking. But in this case, we were using t for time. All right, that's all for example 6. If you have any questions, please let me know.